you have not already done so. Short today. There's something going on. It's just a nice day, finally. Just that time of the semester where we're tired.
Sick.
Oh, yeah, there's stuff going around.
There's also the internship going on.
Oh, okay. I didn't even realize that. Where at? Oh,
In the health building.
okay. It sounds good.
I should have went there.
I tell you what, folks, we're gonna give it like 2 more minutes. Maybe I'm wrong, and people are just missing class, but there's a lot of folks missing who I don't normally miss, and if they do, generally communicate with me, and I haven't heard from them. So we're just gonna wait 2 more minutes. So, see, right, there's Grace. So there's one of them. It was in that list. It usually communicates to me. So talk amongst yourself for 2 more minutes, and then we'll just get started a little late. I'll put music back. Actually, I won't put music back on because I started recording, and then when I upload it, I get a copyright violation and it makes me edit it. Are people excited for Halloween?
No. Yes.
Even as a kid, I don't know, I never liked Halloween.
I don't like Halloween.
Don't like dressing up.
Neither.
Don't know why. But
I think I don't like New Year's and I don't like Halloween, and I think it's because there's added pressure for it to go really well, and it never goes well. So I'm always very disappointed. I like the idea of Halloween. I like the idea, but I always end up like.
I like scary movies, or like cheesy scary music. Cheesy scary movies.
My ideal Halloween is I'm gonna be at home, watching TV, watching some Halloween movies, cooking cocktails, same, full cups of pumpkin. That's what I want. Honestly, my ideal Halloween, I'm going back trick or treating. Oh yeah, like I think so. How about the parties at school? If people open the.
All right, folks, let's go ahead and get started. If you just walked in, go ahead and check in for me. All right, quick review before we get into new topic. So last week, we talked about correlations. So correlations are when we have positive correlations and negative correlations. Positive correlations are best friends. They go everywhere together. They're always moving in the same direction. Negative correlations are enemies. They're repulsed by each other. They're always going in opposite directions. When we run a correlation, we get a correlation statistic that ranges from +1 to -1. Anything in the middle here, we consider weak. Here between the 0.3s and 0.5s, we would consider moderate, and at the edges, we would consider strong. Now, these are the kind of rules of thumb. Because we deal with people, like you will hardly ever see anything that's a strong correlation just because there's too many factors influencing things. So if you get something moderate, that's quite telling. I gave you these examples. So if we have a positive correlation of 0.98 between study and test score, that means the less you study, your test score goes. The less I try to squish it up on you, the less you study, the test score goes down. Or so positive doesn't necessarily mean it goes up, it just means they go together. Just means they go together. Okay. So yeah, the more you study, the higher your test score, the less you study, the lower your test score. Both of those are true. Okay. The more alcoholic beverages you consume, this is a negative correlation. The more alcoholic beverages you consume, your test score goes down. Or, okay, you could say, the lower your test score, the number of alcoholic beverages you consume goes up. Yeah, it doesn't actually tell you. The statistic itself doesn't tell you what order they go in. And then we learned, I didn't put it up here, we did some little experiments here. We learned that the more you sleep, the more games of rock, paper, scissors you win. Okay. I think it was a moderate relationship. Okay. And we learned that the faster I talk, okay, the fewer things you remember. So we had a negative correlation there. Small, but we were small samples. Here's some data. This is our last semester. I didn't do this for you all because it wasn't that interesting, but I'm going to use this as an example. So last semester before the exam, I had them complete a little survey, asked how much they slept. So between number of hours sleeping and grade, we had a negative correlation. This parentheses mean negative. You'll often see this because if you just put the little dash, it's hard to see. Okay. We had a negative correlation of 0.3. Tell a friend what that means. Take 15 seconds. Go.
So you wouldn't see it, you weren't here, so. The correlation is positive, so if they're positive, then you just do negative 1 and 1. So if it's in between 0 and 0.3, like the exact relationship, but realistically, most like realistic heroes.
All right, let's see, because I heard your voice. Colton, Otter,
Even.
it is even. Your row or another one?
Let's go 3.
Okay, row 3. Did you have a question first? Okay, go for it.
In terms of like when it's like exactly like 0.3, what like, oh wait, let me. I just had a question, but we can like have like the third row like.
Okay. All right, third row. Colton threw you under the bus. The more you sleep, your exam score does what? Goes down. Yep. The more you sleep, the exam score went down, which is not what I was hoping to find out, but these are what the data told us. Now, I can tell you before you go like, great, I'm not gonna pull on, like there was, because we were a small sample size, one person skewed this data. I had one person pull an all-nighter that got 100 on their exam. So they totally screwed up that data. In general, I don't recommend it. Time of completion, okay? Again, negative 0.25, we could round that to negative 0.3, so we could say that's moderate. All right, Kendra, odd or even?
Even.
It is even. Your row or another one?
Another one.
Okay, what row?
1.
Oh, I thought you were going back. What is it with you guys? All right, row 1, the longer you take to finish your exam, your grade. Negative correlation, so they go opposite directions. So the longer I take, the grade goes down. Yep, it goes down. Weak to moderate, so it's not like if you're taking a long time, don't panic. Okay. So I asked folks before the exam how confident they were feeling. I asked them after the exam how confident they were feeling. After the exam, we had a positive correlation of 0.40. 0.40. All right, Megan, odd or even?
Even.
Even. All right, pick another row, unless you want to
The
just pick.
last row.
Yeah, all right, yeah, going after you last row. All right. The more confident you felt after the exam, your exam score
Went up.
went up. The less confident you feel after the exam, your exam score down, yep. Okay, it doesn't tell us which direction, it just tells us, are they together? Are they moving together, or are they moving in opposite directions? Yeah,
Does it matter if it's in the parentheses or not?
so the parentheses here means negative. Okay, so
Okay, I
we
didn't-
do that instead, because if you put the little dash, the little negative, it's hard to see. So parentheses is another way to say, mean. a
Oh,
negative.
just for your right now.
Yeah, Q.
So when it's like directly like 0.3, like how do we differ, like when it's a weak relationship and it's a
That'd
moderate?
be moderate.
So when
for
it's
sure.
like 0.29, then
That
that
would
would
be
be
weak.
weak?
Yeah,
Oh, okay.
yeah,
So when it's like 0.3, we're always
Yeah.
gonna go moderate?
yeah.
Okay.
Which is arbitrary, really. Mostly I want you to learn about what that means. All right, this one I found kind of interesting. So we asked people how many hours at their current job they worked, like in the last 5 days, okay? We found a negative point 0.08. Okay, negative 0.08. It's a little tricky. So the more hours they work, the exam score. Yeah, a little bit, but it's really such a weak relationship with, so there's not much relationship there. Very little relationship there. All right. Questions about correlations? So where we're gonna take this Thursday, and this information is like the so what? What does this mean for management? So we learned that the more you sleep, the more games of rock, paper, scissors you win. So if I'm a manager managing a rock, paper, scissors team, I'm gonna tell them to take longer naps. So how do you do that? Joe?
How do you deal with anomalies that would skew the data?
You just need a larger sample size.
You would never eliminate that result. I mean, what if you couldn't get a larger sample size and let's say it's 100 and now two of the outliers are gonna skew the deviation?
Yeah, then you'd eliminate outliers, and there's a whole process for determining what's outliers. The other thing you can do, and I'm gonna use that to transition today, is look at the statistical significance. Okay, let me transition that. So today we're going to talk about what we call inferential statistics. Inferential statistics. So these are statistics that allow us to make an inference, to take one piece of data and infer something else. So somebody, maybe it was. So Hayden has some like an adventure sticker on her water bottle here. So from that, I might infer that she's a Parks and Rec major. I'd actually be wrong. But it's taking that piece of information and inferring something else. Okay. And the specific thing we're gonna look at today is tested differences, but it's really all about these inferential statistics. Okay. This is the hardest thing we will do all semester. The hardest concept we will cover all semester.
Breathing.
Breathing, maybe, right?
Oh, we are.
Fair point, Savannah, a good point. Sometimes I have asthma, so it is sometimes. I want you to breathe and relax. It is difficult. This is what I call a stretch skill. So I'm gonna stretch your brain a little bit. You're perfectly capable of doing it. Okay, we'll go as slow as we need to. And also because I know you care about grades and stuff, even though I don't. This will show up on your exam, but it's like these teeny points, like in the grand scheme of things. So if you're today, at the end of the day, like I completely lost, then just don't worry about it right now. You're not there yet. Okay. And that's okay. That's okay. But I think most of you can get there, but we're gonna stretch your brain a little bit. And we're gonna breathe our way through it. Before we get to inferential statistics, we need to review a little bit of sample and population. So remember, this was our M&M's day. So our population is everybody we're interested in. Everybody we're interested in. Our sample is who we can actually get data from. okay, who we can actually get data from, okay? So what I want to do with inferential statistics is take data from my sample and make an inference about the population, make a conclusion about the population, okay? So let's say I got data from Megan and Kayla, and I'm gonna take whatever I find and make an inference about all of you. That's probably not a good idea, it's only two of them, but that's the right idea. Okay, that's the right idea. So let's wrap our heads around this concept called statistical significance, which I'm guessing most of you at least heard this term, right? Yeah, or that's statistically significant. I guess also as you've kind of heard this term, you're like, it means I don't know what it means. Okay. Okay. Statistical significance is the idea that your results are not attributed to chance, but are attributable to a specific cause. Something is statistically significant if we are confident that our results can be attributed to a specific cause and not just random chance. Let's talk about puppies. Let's say you came home, okay, to this. Most likely, you're going to infer that the puppy destroyed the house. Yeah. Is it possible that the puppy did not destroy the house? Yeah, it's possible. Okay. There may have been a random windstorm that came through, tore all the wallpaper off the walls or whatever else was going on here, I don't know. A raccoon, it could have been a raccoon got into the house, exactly. Okay, so it's possible it wasn't the puppy. So you guys have two choices here. Okay, you have a hypothesis that the puppy did it. So you have the very guilty looking dog here. And you have what we call the null hypothesis, which is, in this case, the puppy did not do it. This is my puppy, who would have totally done it. Okay, totally done it. Okay. So the puppy did it, or the puppy did not do it, because the null hypothesis. If something is statistically significant, it is highly unlikely that your null hypothesis is the case. It's highly unlikely that the puppy didn't do it. So we would say we reject the null hypothesis. We reject the null hypothesis. If we reject this option, then most likely this is the case. Now, truth is, there still could have been some other reason. It still could have been a raccoon. Okay. What we're rejecting is the idea that the puppy did it. So we reject the null hypothesis. To be honest with you, I tend not to get wrapped up in that language of null hypothesis and rejecting null hypothesis. I found that some of you have taken stats classes and you learned that language. So that's why I briefly introduce it. But we're going to move on from it a little bit. There's lots of ways to use statistical significance. For our purposes, we're going to talk about, are things different? Okay. And for starters, we're going to talk about if we have two groups, are they different on some characteristic? So let's say I wanted to know if tourism majors were better students than other majors. Okay. And I gave you an exam, okay, and I looked at your grades, and I took two tourism majors, their average grade was a 90, and I took two other majors and their average grade was an 88. Okay. So that's my sample, right? What I really want to know is, does that apply to everybody? Does that apply to everybody? In other words, okay, for my sample, they were different. But what's the likelihood that tourism majors are really different than everybody else? Or was it just like unlucky that I picked those two people? Okay. Is there really a difference going on, or is it just by chance? So is there a really difference? So we're gonna start with t-test. T-test is what our focus is gonna be. Is there really a difference? Okay, I have this difference from my sample, but in the population, is it really there? Is it really there? Oops, sorry. So we're gonna compare two means to two average scores. So in my example, I had an average exam score for tourism majors, an average exam score for everybody else. Two average scores in the sample. Okay, I want to know, is that a real difference or is it just by chance? Okay, is there actually a difference in the population? There actually a difference in the population. So what a t-test will tell us, a p-value, given this difference in our sample. Okay. Given the difference in our sample that tourism major scored 90, everyone else scored, or the other two scored 88. Given that difference in our sample, what's the probability? Probability is what's the likelihood? What's the possibility that that difference doesn't exist in my population? Okay. What's the probability that the null hypothesis, there is no difference, is the case? Okay. So given my difference in my little sample, okay, what's the probability that that difference does not, that's where it warps your brain a little bit, because you want to see those. What's the result that not exist in the population? Okay. Or to say that another way, what's the probability that that difference was purely by chance? That the difference was a fluke. I just happened to draw the wrong two people. Okay, I just happened to draw the wrong two people. All right, let's use some examples. Ironic, we were just talking about this. Let's say I have a group of Arizona State students and a group of University of Arizona students. And let's say, sorry. Okay. Let's say I give them this question, rate your agreement with the following statement. I consider myself a happy person, okay? 1 is strongly disagree, 5 is strongly agree. First of all, what level of data is this? Nominal, ordinal, interval? Interval, great, okay. Okay, so I ask a sample this question. I'm not gonna ask all 140,000 Arizona State students and however many Arizona students there are. I ask a sample, okay? I had a sample of 1,000. Okay, so 50 ASU students strongly agreed, 130 agreed, 80, you get the idea. And I have the same thing for University of Arizona students. Okay. 1,000 in each sample. On average, my happiness score for ASU students is 3.08. Okay, my happiness score for University of Arizona students is 2.83. So in my sample, I see a difference. Based on these 1,000 people, I would say that ASU students are happier than University of Arizona students. But are they really? Okay. Are they really? What's the probability that this is really the case if I had everybody? And what's the probability that this was? Okay, this was just a fluke. Okay. I'm gonna show you this visually, which is one of those things, some people helps and some people it's like, no, that doesn't work for me. So see what you think. So if I were to plot this out, let me go back, okay. 55s, 136 fours, 683s, etc. I would get two graphs like this. Okay. So you see that, how many fives, that's how many fours, threes, twos, ones. Oops. Let's see if I can. really wanna. Let me try something. I want to draw over this. What, I know neither is perfect. We'd rather we draw here, over there, or raise this up and turn off the projector and draw in the middle.
Sides are fine.
Sides are fine. We can see, right? All right, so, what I could do here, so I have this data, I can draw this nice little line, which some of you are gonna recognize and say that's a bell curve, that's a normal curve. It's okay if you don't recognize that. So I have, let's call this, these are ASU students. So blue is ASU. If I have the entire population, and it's perfectly normally distributed, but you don't need to know for purpose of this class, but it's gonna be. This is my average score. It's gonna be like 3.08, right? Okay, so here would be like 3. Okay. I could do the same thing with U of A students. So I'm gonna get something like that. In this case, here's my average score. Let's say it was 2.83. Okay. The Arizona State students, higher average happiness than Arizona students. And this is my population. This is everybody. So we have everybody. Now, when I draw from a sample, I'm not gonna draw everybody, right? Close my hands, I'm gonna get these 1,000 people. Okay, you'll notice some places in this. Okay. I didn't do a very good job, but in some places here, for example, U of A students are actually higher than Arizona State students. Okay? Because it never perfectly aligns. There's some places that you're gonna see the opposite. Okay, I may draw 10 people, and those 10 people might on average be happier Arizona than Arizona State. Okay. The p-value, okay, is the probability that I draw from those tails. I draw from where U of A students are happier than Arizona State students, okay? It's the probability that when I close my eyes, I happen to have 1,000 people where Arizona students were happier than Arizona State students. Even though if I had all 140,000, I would see the opposite. Okay, so the p-value is the probability that I draw from, I'd say I draw literally from where Arizona is happier than Arizona State. If that visual completely lost you, then just flush it out of your mind. Sometimes somebody's like, now I get it, and sometimes people are like, I have no idea what you just did, which is all fine, all fine. And the other way we can compare groups is to do one group at 2 different times. Okay, so in our first example, we had Arizona State students and Arizona students. We could look at Arizona State students, how happy they were. Let's see, before my picture is sad or happy, it looks sad. Okay, before the Cincinnati game on Saturday. Okay, how happy they were after the Cincinnati game. Okay. And again, let's say we have 140,000 fans. I'm not gonna survey all of them, I'm gonna survey 100. Okay, my 100's gonna tell me on average, those 100 people were less happy. But what's the probability that's actually the case for all 140,000? Okay. That's what the p-value is telling us. So P stands for probability. Slides get weird. So p-value is the probability that given the difference in your sample means, probably that difference does not exist in your population. Given the difference in your sample means, p-value is the probability that that difference does not exist in your population. .3. These are my happiness scores from a sample of 1,000 people. Given these scores, what's the probability that that difference does not exist in the population? I just kind of ballparked it around that. Let's say that our p-value is 0.02. We actually can think of this as a percentage. So 0.02, if we were to convert that to a percent, it would be 2%, right? So given that this difference, there is a 2% chance, only 2% chance that that difference doesn't exist if I had everybody. There's a 2% chance that there's not really a difference. So when you hear statistical significance, it means that this is low. Statistical significance means it's highly unlikely that that difference does not exist in the population. Someone's like, can't you just say it's highly likely that the difference does exist? Technically you can't, and I'm just gonna say, trust me, because I'm already hurting your brain enough. 2% chance that that difference does not exist in the population. Okay, if there's only a 2% chance that this difference doesn't exist, do we feel pretty good about the difference? Yeah, we feel pretty good about the difference. Would we technically say that's statistically significant? Let's see. So lower p-values means there probably really is a difference in the population. Really, probably really is. In general, we want to see differences, so we like lower p-values. So if we have a p-value of 0.03, that means given that difference in your sample means, that big or bigger, so in other words, at least this much difference between 3.2 and 2.8, but it could be even bigger. Okay, there's a 3% chance that difference does not exist in the population. Or if you want to say there's 3% chance that difference is a fluke. It was bad luck that that's the sample we drew. Bad luck, that's the sample we drew. If you take in a stats class, you may have heard this magic number 0.05. Less than 0.05 is statistically significant. That is usually the number we use as our cutoff point between this is significant, this is not. Here's how that number came to be. This is a bit of silly history, but who knows. The guy who came up with this whole statistical calculation and p-values was at a conference and people were bugging him. Like, okay, well, that's nice, but like, what number do we want? Like, what should it be? And basically he just had it with him. He's like, I don't know, 0.05, and it stuck. So this number is completely arbitrary. It's we use it, but it's completely arbitrary. Because you think about it, like, let's say I had 0.49, we might say 0.49 is statistically significant, but 0.51 is not. So you're telling me that something there's a 0.02 difference in, one's significant and one's not? Come on. But that is the magic number we use, 0.05 of statistically significant. I'm more interested in you being able to interpret that. So 0.05 would say there's a 5% probability that that difference does not exist in the population. But you will hear that, so you know it. All right, let's practice. You all know I like to play rock, paper, scissors. All right, so we're gonna do two groups, okay? All right. You go, Grace, you're gonna go that way, and you're gonna go that way, Sven, you're gonna go that way, okay? You're gonna play rock, paper, scissors again, but a little different variation of rock, paper, scissors. This game is called evolution. This is the way evolution works. Your goal, the stuff we're doing takes a lot of brain work, so we have to be silly sometimes, okay? Your goal is to evolve from egg to superhero. This is not a biology class, no one critique the biology, okay? Everybody starts as an egg. If you win, you move up. Okay? When you go to chicken, when you go to dinosaur, when you go to rock star, when you go to hero. If you lose, you move down. Okay? If you lose as an egg, you stay as an egg, okay? Okay, when you move up, lose, you move down. So far, so good? One and done, rock, paper, scissors, go. Win and move up, lose and move down. So far, so good? All right, so you might be saying, okay, well, who do I play against? You have to play against people who are at your level. This is a caste system. Chickens don't associate with eggs, dinosaurs don't associate with chickens. It's a caste system game. Okay. So how do you find people at your level? You're an egg. You're a chicken. You're a dinosaur. T-Rex. You're a rock star. And you're a superhero. Sound effects encouraged, not required. Okay. So everybody starts as an egg. You play another egg. The loser will stay an egg. The winner will become a chicken and will have to find another chicken to play against. Okay. Try and miss all the things you have to remember now. Try to roughly remember how many games you win. I missed everything else you're trying to remember, but you can guess.
How many you win?
Yeah, how many you win? Yeah. You can guess at the end of the day. Okay. What questions do you have about what's about to happen? Yeah.
Are we just going once or?
Yeah, just once. See, every time someone wants to play best 2 out of 3, every time. Okay, just once, one and done. Okay, if you tie, keep going till someone wins. Move up. Okay, or move down. You can only play against people at your level. Hey, I told you it's not a biology class, all right? If you want a biology class, go take a biology. Part of your attitude. All right. All right. What questions do you have? Yeah.
After here, are we done or?
Yeah. We'll play another round, but once you're a hero, you win. We'll see if there's another hero and then we'll.
Oh.
Questions, comments, snide remarks. Maybe don't answer that. Okay. Go.
Do you want to play or? Okay. Are we on the stand?
No, I think it's.
Oh no, is it by side or is it? I'm saying side.
It doesn't matter. No, you can beat against anybody.
Dinosaur. Wait, so I'm back to. Yeah.
Cassie's looking for another dinosaur. We have a dinosaur hiding in the corner over here. We have another heroes. Find another hero.
Dinosaur.
Hero, let's cue. And keep going, just keep going. Just keep going. That was too quick. So wait till someone else becomes the hero.
I'm back to a rock.
Oh, you're not. No. One more minute, one more minute.
I'm a dinosaur now. I think I'm
30 seconds.
tired out.
Seconds. Yes, I'm up on 5, 4, 3, 2, 1. Freeze. Return to your seat.
Which way? Down to the cave. I think you can say it's I did like around.
All right. Left side of the, well, my left. Okay, this side of the room, I'm gonna ask you how many games you won. Kayla.
6.
Megan.
8.
Q.
I'll go with 6. I really don't remember.
Abby.
9.
Grace.
5, but somehow I stayed at egg.
Summer.
I think 4.
Grace.
I totally forgot.
I'll give you 5. Joe.
5.
5. Cassie.
3.
Right. Anybody on the left side of the room I missed? Okay, right side of the room, Savannah.
5. 5.
Yeah.
3.
8. 6.
Grace. This Grace.
Me?
Yeah.
Oh, I went for the.
No, she's-
Oh, you're on the other side. All right, cool. 4.
7.
6.
4.
I'm gonna just increase our sample size just by basically repeating this. Because we're more likely to get an interesting result. So p-values are a function of how big the difference is and how big the sample is. Because right, just logically, if you think about it, if I have a sample of 2, there's a strong probability this isn't hard enough without me being able to talk correctly. If I have a sample of 2, highly unlikely that I'm confident that that's true of the population. So that's why sample size matters. Yeah.
Is it just me or has it always just like automatically shown the average in the corner and the count and the sum, like when you highlight it? Like if you go back, you see like in the corner right
Oh,
there?
It does, yeah.
And
It does
every
down
sing-
here.
Yeah, every
Yeah.
single time you
Oh,
change it,
they do
it
that on the-
like
Yep.
shows the average. I didn't know it like automatically did that.
I never realized that.
Yeah, honestly.
It's interesting.
She's an Excel girly.
Okay. On average, excuse me. On average, so this side of the room, my left side of the room, won 5.5 games on average. Okay. And that would be true even if I didn't triple it. Okay. On average, this side of the room won 5.1 games. Okay. So, I could take that and I could say, okay, people who sit on the left side of the room are better at rock, paper, scissors than people who sit on the right side of the room. But this is a really important question to me, so I'm more interested than just this class. Okay, I'm interested in an entire population of college students. If I should tell them where they should sit if they want to be good rock, paper, scissors, okay? So I've got my data from my sample. My sample tells me that people on the left are better than people on the right. But what's the probability that's really true? Okay, so we're gonna run a t-test.
Oh, we group it, yeah, we're, yeah.
Like down, that's how it's on go right now.
Or I could down a route, though.
Never had a rap.
They're fire.
There's like lemonade soup for me every time.
Yeah,
Like, they're frozen strawberry.
I've always said in California, like we need a fast, like a drive-through health food place. If you go in like LA, obviously there probably is, but. Most are not, so I love Sound. It's so cheap.
Yeah. But the lines are always so
Or-
long. I'm like, guys, you don't have to eat healthy too. Like,
I was saying myself, it's my health kick, like. Don't do this.
All right, I ran my t-test. I got a p-value of 0.05, 0.052 to be exact. 0.05 is my p-value. Okay. And I want to know, is this really apply to the population or not? Okay. Take a minute, help each other out, explain what this means. Talk to each other. Go.
Well, he's under 0.5 is.
Yeah, 'cause
Oh my God.
more than they.
I didn't even thought the other zero. Zero behind.
Zero.
Greater than point oh two.
So there's like a.
No, it's 0.05. It's, yeah, it's 0.5. Not even.
Yeah, but it was.
Anything that's-
5-1.
So, but there's another zero
Like.
after this. Oh, no, it's. I thought it was 0.5 is, under 0.5 is statistically significant.
And then above, like 0.5.
Well, it had parts of it.
Point zero. Once you're like.
Yeah.
It is, it's like anything that is under, anything that's 0.05.
So technically, it's not significant.
Well, that's-
Because it's technically above.
I put 0.5, not 0.5.
All right. You can hear me now, clap twice. All right, I won't pick on anybody this time because it's hard. All right, I'm gonna get you started. Given the difference in our sample means, the difference in 5 win, there is a what percent? 5%, okay, 5.2 technically. Okay. 5% probability that this difference does not exist in the population. Another way to say that, given the difference in our sample means, there is a 5% probability that that difference is a fluke. That it doesn't really exist, that there isn't really a difference. 5% chance, this is where I kind of hate that magic number of statistically significant. We would say this is not statistically significant. This is above 0.05.
If it's not significant, it's not statistically significant.
Then I would say, what side of the room you sit on is irrelevant to how good of a rock, paper, scissors player you are.
The wording is
The wording is funky, yeah,
how you like state it.
Yep. the wording is funky. So as we think about this in management recommendations, again, if I want you to be a good rock, paper, scissors player, what side of the room do I tell you to sit on? It doesn't matter, doesn't matter. Okay, it doesn't matter. If this would have been lower, it would have mattered. It's a bit arbitrary. Okay. All right. I want to know if sharing a funny story improves your mood. So on iClicker, Tell me your mood. So A, you're miserable. 5, or E, you're very happy. And then you can kind of guess right in between.
You want right now?
Yep, right now.
If I'm not very happy, but I'm not miserable.
Then you're somewhere in the middle. You can decide.
Are you gonna tell a funny story?
Yeah.
No, because you don't want my funny stories. We're gonna tell each other. My funny stories, no one else thinks are funny.
Well, we wouldn't know unless we tell one.
I feel pressure.
Don't feel pressure. He doesn't have.
I can just be Washington. Folks, did anybody watch, have seen the Washington Dream? It's on Saturday Night Live. It's like this George Washington talking about his dreams for the country.
I love Saturday Night.
I've honestly never watched like a full episode.
I just see the clips. I need to watch the news.
Yeah,
No.
look up Washington's Dream.
The new SNL is trash. The old ones from like.
All right, everybody answered?
Yeah.
Okay. Now, while. All right, let's see if that improved your mood. So, same question.
Speaking Big Mac, you think it's actually good?
Okay, closing in 5, 4, 3, 2, and 1. Your average. Okay. On a 5-point scale, your average before we watched the skit, your average happiness was 2.8. Your average after we watched the skit was 3.7. So quite a big jump there. Okay. But I'm not just interested in you. I'm interested in the population of all college students. So let's see what the probability is that this exists for all college students. Again, I'm going to make our sample bigger because I'm more likely to get an interesting result. I accidentally deleted a number and redid it, so the numbers changed just a little bit. So you may see this occasionally. You might see somebody say p-value of 0. That is impossible. Just doesn't have enough decimal places. We have to go way out. So 0.0003. So if we were to make that into percent, it's actually 0.03%. So less than 1%. Okay. Take 30 seconds. Tell a friend what this means. Go.
It's Yeah,
it's
significant, highly.
No, it's statistically significant, so it's not.
But you can add it 5 times fast.
Okay, we can.
If it's less than the 5%.
I've seen it before.
But if it's greater than.
So if he's not right now, then what?
There isn't a new season,
And
but
then
it's just a
really
great
like
show. Yeah, I feel like it's a
opposite,
really good
so
show.
lower than 5.
Apple
Or if
TV
it's
has a
greater
lot
than
of really
5,
good shows too, right now. Apple TV
I
Plus,
still don't.
I'm literally beginning.
You hear me now? Clap 4 times. All right, I'll get you started. So given this difference in our sample means, okay, so given the difference between 3.71 and 2.83, there is what percent? 0.03% chance that that difference,
Is statistically significant.
it is, but that is correct. But tell me the technical, what does statistical significance mean?
It does exist, it would exist,
That what would exist?
the difference.
Okay, there's a 0.0. I think you know it, it's just confusing,
it-
it's just confusing, because it's the opposite of what your brain
That it
wants to do.
wouldn't exist?
Yeah, because 0.03% chance that it does not exist. Okay, but that's like almost 0% chance that it doesn't exist. Yeah, it's a brain warp.
This whole time, this
It's
is
a
what
brain
it's
warp.
been.
Okay,
Okay, wait.
given this difference, there is a 0.03% chance, so all very tiny, that this difference doesn't actually exist. There's 0.03% chance that there's something else going on.
So then
That
you
difference
know-
was a fluke.
So then you know that there is a difference, cause
Then
that's,
you feel pretty confident there's a difference. Yep. Yep, sorry, Paige. Paige just gave me, I suspect Paige just looked was what a lot of you were feeling. She just gave like this. Yeah,
Okay, so with that, so there is no significant difference.
it is significant because it's below 0.05. Yep, remember significant is below 0.05. This is 0.0003. This is way below 0.05.
So there is a significant difference.
There is a significant difference.
Okay,
it's,
okay, I
It's
think
just
I
not
got
that
it.
it's 0.03 chance that there's not a difference, is that?
Correct.
Okay.
Yeah. I know.
I just got lost.
I'm
Yeah.
thrown off.
So, I mean, I think one of the challenges is there's a couple different ways to say it. Find the one that works for you.
Yeah, I think that.
So, given this difference from our sample, there is a very small chance that that difference doesn't actually exist. Therefore, that difference is statistically significant. Given this difference, there is a very small chance that that difference was a fluke. If I'd have done that with a different set of people, I'd have gotten it, like, I wouldn't have seen a difference.
Okay.
Yeah, it hurts your brain, I know.
On the exam, can we just say like it is or is not statistically significant? Or is that not
You're gonna,
enough?
if you do that, you're gonna get partial credit and you're gonna get a snarky comment from me that says, what does that mean? You can say on the exam, you can say, there's a very small chance that that result is a fluke. Sometimes people like that language just because it's a little more common, right? That's a fluke, that the difference doesn't actually exist in the population. I'll take any of this. Okay. So, if you're a manager and you want to improve people's mood based on these data, what would you do? Bless you.
Play a video.
Hmm?
Play a funny video.
Play a funny video, yep. Play a funny video. Because we saw that your mood increased. Okay, and there's a very low chance that that was a fluke, that there was something else going on. Okay, or a very low chance that if I did that for everybody, I'd get a different result. This is why I put the breathe up front, Savannah. This is difficult. I would say, if this makes you feel anywhere, this is, I would call like an introduction to graduate school statistics. That's where we're at here. In a graduate school statistics class, you would cover this in like your first week or two, but you're still in graduate school, so.
I'm not sure doing this in math.
I didn't go for grad.
My psychological statistics class sophomore year. I didn't really do that. I do like equations and stuff.
I'd rather be tied to the back of a car in class.
Are you planning on doing that?
You're not. Max. Not for me, okay?
I'm gonna,
It's like different.
I'm gonna just tell you one other thing. This will not show up on the exam, but sometimes this is one that people can get fairly easily. This is kind of a variation on correlations. We'll just call it regression. May remember this from high school math. Slow. Okay, formula for a straight line, right? Okay. So slope, intercept.
Got me thinking the beams.
Anytime I have two interval variables, I can plot them. So let's do exam score and study time. Okay. So let's say this person studied for an hour, they got a 50. This person studied for 2 hours, they got a 75. This person studied for 3 hours, et cetera. So I can plot everybody's scores on this, right? Okay. Then what I can do, the computer would do it for me. I don't know why. I would draw a straight line to get to as close to those dots as possible of the line of best fit. Okay, if I have a straight line, I can now calculate this formula. Right? Okay. If I can calculate this formula, then I can predict. If you tell me how many hours you studied, I can predict your exam score. The closer this line is to all the dots, the better the prediction. That is called regression. That is probably the second thing you'll cover in a graduate level statistics class. You don't need to know that, but sometimes people find this an easier concept to grasp than p-values. So, although these have p-values too, but I won't get there. I won't go there. What questions do you have? Thursday. Okay, so again, I told you this is the hardest thing we will do all semester. Conceptually, done. I promise. It gets easier from here on out. Okay. And in fact, we would say we're on like a downward slope, but it'll get easier and easier. Thursday, we're gonna go, okay, we're on t-taps, we've done correlations, we've looked at crosstabs. So how do we use that data to make management decisions? So basically, we're just gonna like show you some bits of data, give you some situations, be like, you're the manager, what do you do? Okay. I have people sleep more. I tell a funny story. I don't tell a funny story. Okay. I sit on the left side of the room. It doesn't matter which side of the room I sit on. So we've already kind of teased it. Okay. So that's what we're gonna do on Thursday. Next week, we're gonna talk about how we read an academic article. And I'm gonna give you some kind of shortcuts to doing that. Because they oftentimes, I think for you, there's a lot of like mumbo jumbo in them. So I'm gonna give you some shortcuts for how to do that. Okay. So that's where we're going. You'll have an exam coming up. The exam is like 3 weeks before the end of the semester. That way we can focus on your project for the last few weeks. It's one of those, when we take the exam, you hate me, and then you're like, that's great, because now I don't have it at the end of the semester. I don't know, someone have it in front of me. I don't know, it's like 3 weeks before the semester roughly. But you got a few more weeks, you do have app 4 coming up, which is due tomorrow, okay. Yeah, so if you have questions, shoot those to me. Again, try not to abuse it, but you do have a 3-day grace period there if you need it, as long as people aren't abusing it. It's all good. Questions you have? All right, folks, nice job today. That is, I know it stretched your brain. That is not easy stuff. Like I said, that is graduate level stuff. And I think, I know you may be feeling like your brain hurts, but I think you did pretty well. So nice job. Go enjoy the weather before it gets hot again at the end of this week. Let's see you on Thursday.
Yesterday was in the middle of training, but I had a lot to. Palace cars total.
So you've still been driving
Mhm.
for what?
And I feel bad because, like, I will because A, I'm a good person. B, she doesn't have a choice. Yeah. Right, so I will, but also, you have to give me